Bismillahirrahmanirrahim. Today our topic is two-port network. Okay, as the name revealed that in these type of networks we have two ports. So the one is the input port and the other is the output port. Okay, so according to the definition, two-port network or four-terminal network is an electrical network or the device with two pairs of terminals to connect to external circuits. So usually port 1 is considered as input and port 2 as output port. And the practical example of these circuits analyzed as two ports are the filters, as we have already studied before the midterm, and the transmission line. We will discuss the transmission line in this lecture for the two-port network, and you will study the transmission line in transmission and distribution subject as well. Okay, so the transformer, the equivalent circuit, is also a two-port network, and you may study it in electrical machine. And transistors are also two-port network, and you may study it in electronics. Okay, so in two-port mathematical model, the network described by the 2 cross 2 square matrix. And the common model that are used are referred to as Z parameters, the Y parameters, the H parameters, A, B, C, D parameters, and the G parameters. So we will discuss few of these parameters in this class. Okay, so here we go. We'll start with the impedance parameters. So as you can see that we have, these are the input port, these are the output port, port 1, port 2. Okay, and on both side we have the current sources I1 and I2, and we have the dependent sources as well. So dependent sources are, these are the voltage dependent sources, and these are represented by the diamond shaped. Okay, while the sources, independent sources, are represented, are assembled as the circle. Okay, but these are the voltage dependent sources because V is equal to IR. So R12 means this is the resistance common between port 1 and port 2. Similarly, R21 also means that this is the resistance which is common between port 1 and port 2. Okay, R11, it means it is the only resistor of port 1 associated with port 1 only, and it has nothing to do with the port 2. And R22 means this is associated with port 2 only. Okay, this dependent source depends on this current I2. That is why it is called dependent, because this source depend on this I2, where this is also a dependent source which depend on the current of port 1. Okay, although this is linked with port 2, but due to dependency it is linked with this port 1. Okay, so now we will write the Ohm law V1 V2 in the matrix form: Z11 Z12 Z21 Z22 and I1 I2, as we have already done this in Kramer rules in LCA. So now what does Z11 means? What would be the values for these impedances? These are actually the impedance parameters: Z11, Z12, Z21, Z22. These are the impedance parameters. So what will the values? Z11 is equal to V1 over I1, where I2 will be equal to 0. Means this is actually the Z11, okay, and the only current flowing through this will be I1, okay, while it has nothing to do with this resistor, so this current will be equal to 0, means open circuit, okay. So the I1 will flowing through this, okay. So I2 will be equal to, the source 2 will be equal to 0. in, in these impedance parameters, one of these two current sources must be 0, okay, and one must be active. Okay, now Z12, for Z12, as it is dependent on resistance port 2, so that is why Z1 is equal to V1 over I2, where I1 is equal to 0, because it depends on this current. So if it is 0, so it has no problem and no issue, because it already depends on this I2 current, okay. So I1 will be 0 for this case, and Z in Z21, okay, this one I2 will be equal to 0, because this current does not flow through this, rather it depend on this I1, okay. So I1 current will flow through this resistance, okay. So Z21 will be equal to V2 over V1 I1, where I2 will be open circuited. Now Z22 V2 over I2, according to the Ohm law, Z is equal to V by I, where I equal to 0. This is not the dependent resistance, okay. Now moving to the Y parameters, that is called the admittance parameters, okay. Y represent the admittance. So in admittance we have taken uh, the resistance in parallel, okay. So one more Y11, one more Y22, okay, and now we have the voltage sources V1 and V2, okay. These are actually the V1 and V2, okay. And now we have the dependent current sources, okay. The direction shows the current, okay, and now this is the dependent current sources. This current source depend on this voltage, and this current source depend on this voltage, okay. That is why y1 to v2, okay, v2, and y21 v1. Now according to the Ohm law, I will be equal to yv, okay. I is equal to, actually I is equal to v to over z, so no over z means y, so I is equal to vy, okay. So now in matrix form we can write this as this, okay. So now similar method, y1 will what will be the value of y is equal to I over v, okay. So I over v, y11 I1 over v1, because this is not the dependent impedance admittance, so v2 will be equal to 0 in this case. Y12 is the dependent, so it depend on v2, so it v2 must not be 0, rather v1 will be 0 in this case. So y21 depend on v1, so v1 is divided over here, while v2 will be equal to 0. Y22 is I2 over v2 for v1 equal to 0, okay. Now the hybrid parameters, hybrid actually mixture, the combination of z parameters and y parameters, okay. So that is why it is called as hybrid parameters. So this portion has been taken from the z parameters, and this portion has been taken from the y parameter. In z parameters we have seen the resistor over here in series with the current, so in the current source, Okay, and in the admittance we have seen this port 2. Okay, has been copied from this this portion of admittance. So now h1 h11 h12 h21 h22. So these are also mentioned in the circuit. So let's have a look on the circuit. This is h11, h12, h21 and h22. This is actually h22. Okay, so h11 v1 over i1 v2 is equal to 0. So because this is a resistance, h11 is a resistance, so a resistance r is equal to v over I. So v over I, and it is not the dependent. So v2 will be equal to 0. Other side, other port will be equal to, this port will be equal to 0. Now h12. Okay, h12. So h12 is not the resistance. Okay, so it is actually the ratio of v1 and v2. So v1 over v2, while I2 will be equal to 0. And h21 is actually the ratio of two currents, I2 over I1. And in this case v2 will be equal to 0. h21. Okay, h21, in h21 v2 will be equal to 0. This will be equal to 0 because this depend on this I1 current. Okay, this is actually the I1 current, so it depend on this. So for this h21, this will be equal to 0. Okay, so now h22, this is actually the admittance. Look over here, it's actually the admittance we have taken from the admittance matrix. So h21 is I over v. Here h11 is v over I because this was the resistance, but now h22 is the admittance. So h22 will be equal to I over I2 over v2, and I1 will be equal to 0 in this case. Okay, so now ABCD parameters. But before ABCD parameters, we have to represent the admittance matrix, sorry, the impedance matrix and admittance matrix in T and pi network. Okay, so what are the T and pi network? T networks are actually uh, the networks in the which shapes as T. Look, this shapes as T. Okay, this is actually the ground. So we will focus on this portion T, and for the pi it shapes as the pi. Okay, this is again the ground, so we will focus on this portion. So this is actually the pi network. Okay, so these are two actually the methods to solve any network. Either you solve by T network or the pi network, the answer will be the same. So let's have a T network. Let we have a T network having three impedances, Z1, Z2 over here, and Z3 over here. So and in the pi network, the same three impedances, Z1, Z2 and Z3, but in different pattern now. Okay, so T network. Okay, so apply loop 1 to find the admittance matrix, sorry, impedance matrix. So loop 1, apply KVL. We have two loops, loop 1 and loop 2. So apply KVL. V1, this is V1 and this is V2. Okay. Now we have ZA, ZB and ZC. ZC is the common embedded between loop 1 and loop 2. So I1, V1 is the source and these two are actually the drops. And this is the source and these two are the drops in this loop. So now starting from loop 1, V1 is equal to I1 ZA, Ohm law. Okay, this is we can say this is actually VA. And now this is voltage drop which we call VC. So VC is equal to I1 plus I2 into ZC, because two current are flowing and both of these two current are flowing downward, so same direction. That is why we will add up these two currents, I1 plus I2. So I1 plus I2 into ZC, this is actually the drop in the loop 1. So solving the bracket and taking I as common, so we will get I1 ZA plus ZC, and the only I2 will be written over here. Now switching to the loop 2. So again we have the only source V2 is equal to I1 plus I2, because the same current is flowing through the ZC. I1 plus I2 into ZC plus I2 into ZB. Solving the bracket and taking I2 as common, so we will get this. So these two are the two equations. Now writing these two equations in the matrix format, we will get V1 V2 is equal to ZA plus ZC into and ZC. Okay, and now from equation number 2, V2 is equal to ZC. Okay, and ZC plus ZB. So remember, for simultaneous matrix these two values will always be same. Okay, so ZA plus ZC, this is actually the impedance matrix using the T network. Okay, we will discuss the pi network in second portion. Okay, thank you.